Hello and welcome back. These will be additional examples for Chapter 7, Section 2, Solving Systems by Substitution. There is a PDF available if you'd like to print it out and follow along. Okay, substitution means you must isolate one of the variables and then find wherever that variable is in the other equation and then substitute it for what it equals. So we can see right now x is by itself, so anywhere we see an x we can replace it with 6 minus 4y. So this bottom equation, I'm going to take my x out and put 6 minus 4y in place. That's where my x was, and then I continue the rest of the equation. And now I have, instead of two variables, one variable left in the problem. So I'm going to go ahead and solve for y. So I have to distribute here, and I end up with 12 minus 8y minus 3y is equal to 1. So the next thing I'm going to do is combine my y's together and move my 12 over. So I'm going to move my 12 over first. So I have a 1 on this side and I'm minusing 12. And then I end up with negative 11. But when I combine my negative 8y with my negative 3y, I have a negative 11y. Divide both sides by negative 11 and y equals 1. We only have half of our solution, so we have a 1 for y. To calculate the value of x, I have to go and substitute 1 back into one of the equations. I'm going to substitute in the top one. So x is going to equal 6 minus 4 times 1. So that's 6. X equals 6 minus 4. X equals 2. Therefore, the other part of my solution is 2. So the solution to this system is 2, 1. 2 for x, 1 for y. Next example. As of right now, I don't have a variable isolated by itself. However, I can see that this y here has a coefficient 1, so it'd be easy to isolate it. So I'm going to rewrite that equation as y equals negative 2x minus 2. And now, anywhere I see a y in the second or the first equation, I can substitute with negative 2x minus 2. So go up to that first equation. I have a 4x that was already there, a plus 3 times, and in parentheses I'm going to substitute y with negative 2x minus 2 and let it equal 0. I have one variable, solve for the x. This is just a multi-step equation, so I still have the 4x there. 3 times a negative 2x is going to give me a negative 6x, and 3 times a negative 2 is going to give me a negative 6, and that's going to equal 0. Combine the x's. 4 minus 6 is going to be a negative 2. Move your 6 to this side, and that gives you a positive 6 over there. So negative 2x is equal to 6. Divide by negative 2 on both sides, and x equals negative 3. So we have half of our solution, negative 3 for x. Calculate the y. I'm going to go back and put this negative 3 in place of this x right there. So 2 times negative 3 plus y equals negative 2. Well, that's going to give me a negative 6 plus y is going to equal negative 2. Add 6 to both sides, y ends up equaling 4. So the solution to our system is negative 3. Okay, next system, you'll see the coefficients, none of them have 1 on it, so we're going to have to do a little extra work. Now I'm going to go ahead and isolate this y right here, because when I move the 4x over, I'll eventually have to divide by the 2 that's out in front, and both the 4's will divide nice and neat, thus avoiding any fractions in my problem. So step 1, move the x over, and I end up with a negative 4x minus 4 on the right hand side. Next step is to divide everything by negative 2, so I end up with y equal to, this is going to be divided by negative 2, this is going to be divided by negative 2, so I end up with a positive 2x and a positive 2. So y, when isolated, is now equal to 2x plus 2. So take this 2x plus 2 and substitute it in place of y over here. Okay, rewrite that equation, so it's going to be 7x minus 5, parentheses, 2x plus 2 is still equal to negative 19. All I did was take the y that was right there and substitute it with that value. Now, one thing you got to be careful of on this problem is when you start to solve it, you'll have a 7x there, but what you're distributing on the inside here is not just a 5, but a negative 5. So it's going to be negative 5 times 2x. That's going to give you negative 10x. And a negative 5 times positive 2 is going to give you a negative 10, and the whole thing is still equal to 19. Now continue solving for x. combine my x's here, so 7x minus 10x gives you negative 3x. I'm going to take this negative 10 and move to this side as positive 10. So negative 19 plus the 10 coming over leaves me with a negative 9. Divide both sides by negative 3, and x equals positive 3. So half of my solution is positive 3 for x. Now I got to go back and calculate the y value. I always recommend you go back and test your answer, check your other solution in one of the original problems. So use one of these equations here to substitute. Don't use one of your modified equations. And since I'm substituting a 3 in for x, this coefficient's only 4. I'm going to use that one because it's a smaller number. So 4 in place of x, I'm going to put my 3 minus 2y is equal to negative 4. And now just solve for y. 12 minus 2x is equal to negative 4. Subtract 12 from both sides. 2y is equal to negative 16. Divide by negative 2 on both sides. Y is equal to positive 8. So the solution to my system is 3 for x, 8 for y. Last problem here, we have to write our own equations. Okay, a drummer is stocking up on drumsticks and brushes. The wood sticks that he buys are $10.50 a pair, and the brushes are $24 a pair. He ends up spending $90 on sticks and brushes. That sounds like a total. He buys 2 times as many pairs of sticks as brushes. The question they're asking is how many pairs of sticks and brushes is he going to buy? So since they're asking how many pairs of each, my 2 variables are going to represent how many pairs of each. So we're going to go ahead and say let k equal number of stick pairs, and let b equal number of brush pairs. Anywhere I see a k and a b, it stands for the number of pairs of sticks and the number of pairs of brushes. It does tell us that he buys 2 times as many pairs of sticks as brushes. So the number of sticks he buys, which is k, is going to equal 2 times the amount of brushes. So k equals 2b. So there's your first equation with the variables in it, k and b. The next equation is going to come from the cost of the brushes, sticks, and how much he spends total. Well, it tells us that the sticks cost $10.50 each. Well, the sticks are k, so $10.50 times k plus the cost of the brushes, which is 24 times b, ends up equaling a total of $90. So there's your 2 equations. And conveniently, k has already been isolated. So which one are you going to substitute? Well, we're going to substitute k. And anywhere I see k in this other equation, 10.5, I'm going to substitute it with a 2b plus 24b equals 90. Having only one variable to solve for is much easier than having 2. So we're just using substitution to get rid of one of those variables. So I have 10.5 times 2, and that's going to give me 21b plus 24b equals 90. Combine my b's. So that's going to end up being 45b equals 90. Divide by 45 on both sides. 1b is equal to 2. Now b stands for brushes. So he bought 2 pairs of brushes. So we'll call that 2. And then how do I find out the number of sticks? We'll take our 2, substitute it back into one of our original equations. So in place of this b, we'll put a 2. 2 times 2 gives you 4. So you bought 4 pairs of sticks and 2 brushes.